All right, we have a quadratic equation that we need to solve by factoring. And honestly, the first step in any of these factoring problems is make sure that you have one side equal to 0. We do not have that here, but it's pretty easy to make it that way. Just take away the 90 on both sides, and now you've got a quadratic on the left that's equal to 0. Now you're ready to factor. When you factor, you always want to look for a GCF. And, maybe like 4 times out of 5, the GCF will be 1, and it won't do you any good. But here we actually have a GCF of 2 that we can take out. So I'm going to take out a 2 out of every term. I still want it equal to 0. And the reason you do that is it makes your factoring a lot simpler. All the trial and error that goes along with it gets cut in half, basically. I could divide both sides by 2 now. And what that does is it makes that 2 out front go away. On the right side, you still have 0 divided by 2, so you're still equal to 0. Now we're ready to unfoil this thing. I'm going to break this trinomial into 2 sets of parentheses. The x squared comes from multiplying x with x. And then I'm skipping to the end term. The negative 45 probably comes from 9 times 5. The signs have to be different. That's my guess. I'm going to check it by foiling it back out and seeing if I get the trinomial that I started out with. So I'd get an x squared, which I'm supposed to have. I'd get a plus 5x and a minus 9x, which would combine to give me negative 4x. And that's what I want in the middle. And obviously I'll have a negative 45 at the end. So now that I've got this equal to 0, I can set each individual factor equal to 0. So if the x minus 9 equals 0, that means x would have to be positive 9. And if the x plus 5 equals 0, that means that x would have to be negative 5. Those would be your 2 solutions.